So basically we have to check whether nickel in the +2 oxidation state can have two unpaired electrons in which of the following geometries: octahedral, square planar, tetrahedral. We have to apply the valence bond theory. Now we have written the valence electronic configuration of nickel neutral. So nickel in the +2 state becomes 3d8 and there are no electrons in the s orbital. We try the octahedral geometry. The hybridization corresponds to sp3d2. sp3d2 means it has to be an outer orbital complex because we use the outer d electrons, not the inner 3d electrons. So we need to write the 4d up to 4d. Okay. Now we fill the 3d electrons here. Now what we are left with? We are left with two unpaired electrons here. So in the octahedral geometry, which has sp3d2 hybridization, so we have two unpaired electrons in the Ni2 plus oxidation state. So what does this square planar geometry correspond to? It corresponds to the dsp2 hybridization. That means we are using an inner d orbital. Fill the d8 electrons, and then since it is dsp2, that means the last d orbital is remaining vacant. That has to be left vacant so that dsp2 hybridization can take place. Now in order to keep that vacant, what needs to be done? The d8 electrons, they need to be paired up. Now do we see any unpaired electrons here? No, all the electrons are paired. So in square planar corresponding to dsp2 hybridization, there are no unpaired electrons. That means second option is not correct. Now we know that the tetrahedral geometry corresponds to sp3 hybridization. So 1 to 5 singly occupied, and after 5 pairing takes place. So this is how the d8 electrons are filled here. When this hybridization occurs, so 1 s orbital and 3 p orbitals, 4s and 4p, they combine and form sp3 hybrid orbitals, and this is also an outer orbital complex. So inner 3d orbitals are not involved in the hybridization. Can you see unpaired electrons here? Yes, the last two electrons of the 3d orbitals are unpaired. So that means in the tetrahedral geometry also the nickel 2 plus electrons are unpaired. So in octahedral as well as tetrahedral, both these geometries, the octahedral corresponding to sp3d2 outer orbital complex and the tetrahedral corresponding to sp3 hybridization outer orbital complex. So in both these cases we have unpaired electrons in Ni2 plus electronic configuration. It is 4s here, not 1s. 3d, 4s and 4p.